Up next, burning, cutting, dumping. And that's just part of what it takes to make sugar. Flamethrowers, semis going vertical, combines that are downright scary. Just some of the tools needed to make pure white sugar.
Sugarcane. It's an incredible story that begins with burning and cutting and grinding and pulverizing and converting from solid to liquid and back again. We have many miles to travel before we get this in your coffee. I'm with Ramiro Alvarado. He's with the Rio Grande Valley Sugar Growers. This is the inside of a sugarcane stalk. Which part of this fibrous material in here is the sweetest, and where do you extract the sugar from?
Okay, everything that is inside of the casing of the cane is what we're after. And what we want to do ultimately is to extract all of the juice out of here.
To get that juice means we've got to light this field on fire. It's a controlled burn that makes for a more efficient harvest, leaving behind only cane loaded up with sugar.
Attention, attention. It's time for us to light this sugarcane field on fire. Why? Because America needs its sweet tooth satisfied.
First, we spray a fine mist of diesel around the edges of the field to be torched. The fires are lit only when the wind conditions are perfect. We need a fast fire, one that will burn up the dead leaves and only scorch the cane.
This has all been burned, and what's left is what they're harvesting with these ginormous machines. Come in here, scoop up the cane, put it in these trucks to take it to the mill. So, how do you get 30 tons of sugar cane out of the back of your truck? You do it very carefully and without being in the cab. There's a very good reason for that. "50 degrees, that's the angle at which they raise these trucks and trailers to get rid of 30,000 tons of sugar cane that's in the back.
These hydraulic systems can empty the trucks in about 4 minutes.
From here, it's loaded onto conveyors, it's washed and sent on to the hammer mill. Very impressive.
No doubt, cane is tough stuff. It's withstood flames and combines, but it's no match for the next step. Now it gets chopped to bits, washed and sent through a series of mills that crush the cane. In doing so, we are freeing the juice from the stem. The sturdy stalk is now dust, the sweet sap that will become your white sugar all wrung out. Dirt and other organic materials coloring the juice are removed at the clarification station.
That stuff's very rich, though. So what do you do with it?
All of this, as you see it coming down, is loaded into trucks, and it is recycled back into the cane fields as fertilizer.
Boiling the cane juice evaporates the water, reducing it to a syrup.
From here, all of the juice goes to what we call our boiling house. The juice is treated and then converted into sugar and molasses.
The hot solution is fed into a vacuum chamber. When the air is removed, pressure drops, prompting a chemical reaction that creates two things: molasses, that distinctive flavor we taste in brown sugar or gingerbread, and sugar crystals.
Sugar is actually a crystal, and crystals grow here for the first time.
Right, this is where the crystals are developed.
Sucrose molecules begin to bond as crystals, amassing in such volume that in a matter of hours, those crystals are visible to the naked eye.
So after these crystals have been growing for about 10 hours under pressure in these giant tanks, it's time to eyeball them. Still the one part of sugar making that can't be done any other way.
To Ignacio's trained eye, these crystals have grown to the right size, about the size of sugar crystals on your table. But anyone can see this stuff isn't even close to pure white.
So once we've judged whether we have adequate crystals, we've got to take this stuff and put it through the spin cycle.
Right.
Separate the molasses from the sucrose.
Right.
The sugar crystals are suspended in the molasses, and separating those two is the next challenge. These crystals, now 99% pure, are called raw sugar, but white sugar has to be 99.95% pure, and completely free of molasses and microscopic impurities.
I'm sitting atop 55,000 tons of sugar. There's enough sugar in this mountain, in this storage facility in Harlingen, Texas, to feed every single American 1 teaspoon of sugar. In a moment, we're going to show you how to turn that 1 teaspoon of sugar into something you can actually eat. It's on to refining.
From Harlingen, Texas, our raw, unrefined sugar takes to the sea. It's shipped here to the refinery at the port of Baltimore, Maryland. Our sugar would taste sweet enough, all right, but it is filthy. Stu Fitzgibbon runs the refinery. He knows we've got a long way to go before our sugar is 99.9% pure and pristine white.
Raw sugar has about 99% sucrose, which we call sugar, in it.
So in your refining process, you want to extract the 1% of impurities from this raw sugar.
That's right. We want pure sucrose, 99.95.
Refining to reach pure sucrose begins with removing the outer surface of the crystals. Raw sugar's brown coloration comes from a thin film of molasses on each crystal, and we have to get rid of that. First step, mix our raw sugar with a molasses-like syrup known as magma. This stuff is held over from previous batches and blended in this oversized mixer. The molasses molecules on the surface of the sugar crystals bond with the magma particles and are essentially lifted off. We'll then send our mixture into a centrifuge. The magma flies off, taking some of the molasses and a few microscopic impurities like starch with it. We're left with raw sugar liquor, a product that resembles muddy water. There is still a ton of microscopic junk in here, like bacteria, that's a real challenge to remove. So our sugar liquor moves into the ominously named saturator. 2 compounds are being injected into the washed sugar liquor, calcium hydroxide and then carbon dioxide. Their combined chemical properties initiate a reaction. As a result, crystals of calcium carbonate begin to form around any microscopic impurity. Now it's simple. Remove those calcium carbonate crystals and we remove the impurities. Our 4th step in the process is filtration.
And now we're in something that looks like very futuristic, very industrial. These presses, these are the Sweetland presses.
That's right.
What exactly are we doing?
Well, we form calcium carbonate crystals, and the liquid is brown. And now we need to filter that out. So this whole floor is built for the specific purpose of filtering out the calcium carbonate crystals.
These filtration presses are like massive coffee machines turned on their sides, only instead of 1 filter, they've got 72.
So this solution is being pressed from which end to which end?
It's actually coming up in this direction, passing through the cloth. The clear filtrate goes up through the leaf, and the cloth collects the calcium carbonate on the inside.
Our sugary sweet liquid still has a tiny trace of impurities left. We've reached the last step to clean up the sugar solution. Now we use char vessels. This is similar in concept to a water filter. Char is an absorbent, a blend of calcium phosphate and carbon. The char crystals attract the last few microscopic impurities of color molecules into ash. The result? a colorless liquid known as fine syrup. We'll run the liquid through another vacuum chamber, which results in the formation of pure white crystals. They're trapped in the final centrifuge and fed into dryers the size of locomotives.
Most importantly, we have to get the sugar in the hands of the consumer, right, Stu? I mean, without it, it'd be a very bitter world.
Well, we make it sweeter.
And you do that by having like 14 different lines up here that are packaging the sugar, right?
Yes.
Ranging from what to what?
Well, we have anything from a small sugar packet to a 2,000-pound bag.
Well, it's been quite a journey for us here in this story of sugar. Our story starting in much warmer climes, way down south, and ending up here in beautiful Baltimore at Domino's Sugar. Stu, thank you for guiding us through this. Watching sugar go from a solid to a liquid to solid, liquid to solid. To your coffee or tea.